Hey guys, this is a 7th grade task, experimental probability of simple events. Experimental probability, the book describes it, an event is found by comparing the number of times the event occurs divided by or to the total number of trials. Which is basically what this is all about right here. Simple event is just something that occurs one. It's an outcome. So basically, when there's only one outcome for an event, when there is only one outcome for an event. So if I flip a coin and I'm looking to get heads, right, that'll be a simple event. That's just one event. Complex event or compound event is what we'll talk about later. It's basically one or two, it's more than one event that occurs in series. Anyways, okay, so we got an example. A spinner, and here's the keyword there, I underlined it for you. A spinner has 3 unequal sections, red, yellow, and blue. Okay. The table below shows the results of Nolan spins. Find the experimental probability of landing on each color. Write your answers in simplest form. So the key word here again is unequal sections. So if you have a spinner, 3 sections, right? That means one side could be a lot bigger than the other 2 sides, right? So we could have, let's say this is red, yellow here, and then blue here. Obviously, the red's going to get hit more. The blue probably the second most, and yellow will rarely get hit. Okay. If you take a look at this table down below, you see that this was spun how many times? What was the total number of trials? 10 plus 14 is 24, 24 plus 6 is 30. So 30 is the total event. That's how many was the total trials that they were spun. So 10 out of 30 is 1/3, which is basically 33%. Okay. 14 out of 30 in lowest terms will be 7 out of 15, which is roughly just a little bit less than half. It's a little bit less than half of, so a little bit less than 50%. And 6 out of 30 is 1/5 in lowest terms, and that's basically 20%. So when you have unequal sections, the probability of you getting a yellow is the best chance that you got on this spinner. Now, of course, this I totally made this up, but in that situation, this would probably be yellow then, right? The least likelihood of getting anything is going to be blue, so more than likely that's probably going to be blue here. And this will probably end up being, what was it, red? So again, so this would be something very similar to what this spinner would be, unequal. So, yeah, it doesn't mean that you will always have a spinner that's equal. It's just not fair, right? It's not a game that you necessarily want to play with unless you're betting on yellow. You bet on yellow, you have a better chance of winning, okay? So that's experimental. Experimental probability, think about it, is in terms of you actually experimenting, you actually doing it, right? You living it out. You trying to figure out, okay, what's the probability of this happening if you actually do it with your own hands, okay? Moving down further in the lesson, it talks about what a simulation is. A simulation is basically the same thing. The only difference is the experiment would either be difficult or inconvenient to actually perform. So a simulation is just a way to model something that you may not want to actually do it yourself. Okay, so that could be something a computer could do it for you. Now, if we have an example of Another event, another experimental probability. Let's say a toy machine has an equal number of red, white, and blue foam balls, which it releases at random, right? Ross wonders which color ball would be released next. Well, if you have the equal number amount, okay, you'll have an equal chance of getting either red, white, or blue. So it doesn't matter if you had one of each, right? Two of each, three of each, four of each, five of each, 100 of each. The likelihood chance of you getting red, white, or blue would be all equal. Would be 33%, 1 out of 3. So, but here's really the question. So 33% to get either color, right? Would be his likelihood chance of getting whatever color he wants to get either color. But the question here is, the secondary question is describing how would you use a standard number cube, right? Or a standard cube or number cube to predict the answer. Now you know a cube has 6 sides, right? A number cube, instead of having the dots, has the numbers on them. Now let's just say we had a number, basically a die, right? So you would have something like that. And of course, 4, 5, and 6 would be on the other side, which you can't see. So how could you use a number cube, or let's say in this situation, a die, or a paired one of the dice, and you would roll it? How would you describe red, white, and blue on something like that? So remember, we got 6 numbers: 1, 2, 3, 4, 5, and 6. How many colors you got? You got 1, 2, and 3. So you could, if you wanted to, you could have 1 and 2 be red, 3 and 4 could be blue, right? And then 5 and 6 could be white. Okay, I don't have, obviously can't do a white marker. So that's one way you could do it. That's how you could use a standard number cube. So 1 and 2 could be red. So if you roll a 1 or 2, you got a red. If you roll a 3 or 4, you got a blue. That could represent a blue foam ball. Or if you rolled a 5 or 6, that could represent a white foam ball. So that's one way of doing that. And that's what that example means. But for the most part, again, remember, experimental probability is just you actually completing the task that they're asking you to do. And they want to know, okay, based on your experience on what's occurred before in the past, what's the likelihood chance of you doing something next, okay? If it's unequal, obviously you're going to get, it's still going to tell you what the next probability is. So in order to get red, you have 33% chance of getting a red. For a yellow, it was, 7 divided by 15, which would be a little bit less than 50%, and this would be 20%. Doesn't mean it's going to be fair. It just means, based on your experience, right, what you actually do will inform how future predictions will be assumed, right? Will be guessed based on what you've done. So go and complete the lesson that you have before you. If you have any questions, I'll catch you guys on Zoom. And God bless. Have a great one. Bye-bye.